All right, so coming off of last time, we were doing midpoints, distance, formulas. We also got into circles. So in this one, we're going to find center and radius of this circle. So center. Remember, it's always opposite sign of what's inside. So the x is 2. The y would be -4. Radius. So is the square root of what it's equal to. So square root of 9 would be 3, and that would be our radius. So moving into, we are going to be modeling, which means we're going to be working on story problems pretty much, and be able to set them up and show what we're talking about with our equations, with functions. So you are choosing between two long-distance telephone plans. Plan A has a monthly fee of $20 and charges 5 cents per minute for all long-distance calls. Plan B has a monthly fee of $5 and charges 10 cents per minute for all long-distance calls. So express Plan A as a function f for the monthly cost. So per day. We're going to use f of x. So we want the function f for plan A. So plan A said it was monthly fee of $20, 5 cents per minute. So 0.05 m, well, we're using x. 0.05x plus the plus the 20. So monthly fee, so it's going to be $20 no matter what. And then 5 cents every minute. We don't know how many minutes, so we do 0.05x plus that flat fee. We know we're going to do plan B for a function of g. So g of x would equal, well, this one here is 10 cents per minute, so 0.1x plus a flat fee of $5. So flat fee plus our 10 cents per minute. So for part C, how many minutes will the cost be the same? Well, if we want them to be the same, we can set them equal to each other, and we'll solve from there. So 0.05x plus 20 equals 0.1x plus 5. So I'm going to subtract the 5, subtract the 0.05. So 15 would equal 0.05x. If we divide by 0.05, x is going to equal, I am off the screen, sorry, 300 minutes. So big thing here, going to be doing labels with these. That's where I was trying to go with that. So on a certain route, an airline carries 6,000 passengers per month, each paying $200. A market survey indicates that for every $1 increase in the ticket price, the airlines will lose 100 passengers. So this is something where businesses will look at, okay, hey, we're going to get this much for this price. Well, if we raise our price, we're going to make a little more, but we're going to sell a little less, but are we still making more profit? And so they're going to come up with equations like this to determine, okay, what's the max we can charge so that we get our best profit from selling these things, or whatever the case may be. Here it's tickets for the airplane. So express the number of passengers per month n as a function of price x. So n of x equals, well, the total amount of passengers is going to be 6,000. From there, we lose 100 of them for every dollar increase. So if x is our ticket, if we subtract 200 from this, that's going to be how many dollars above 200 we are to know how many hundreds we need to take away. So we can distribute the 100 in, and we end up with 6,000 minus 100x plus 20,000. So the 6,000 and 20,000 go together. We'd have 26,000 plus or minus 100x. And that would be our function there. So whatever our price is, we can put it in there, and that'll tell us what our max profit's going to be. Now, express the monthly revenue R as a function of the ticket price. Take that back. This was just how many passengers are going to go. Part B here is going to give us our profit here, our revenue. So we're going to call this R of X. So pretty much it's going to be however many tickets we sell times our price. Well, our price is X. This was our number of tickets. So all we got to do here is distribute the X in. There we go. So, formulas can create functions, or be created by, they're going to create functions. Functions can be created by formulas. So, a machine produces open box that uses square sheets of sheets of metal measuring 12 inches on each side. Machine cuts equal sized squares from each corner and then shapes the metal into an open box, turning at the sides. So, this is a lesson that is really cool when I can do this in person. We're going to see if I can do this here. But essentially what's going on is this. Is they have their sheet of paper and they're going to cut out well, it's not exactly perfect, but a square of each corner. So if I do this next one, this isn't going to be pretty, but you'll get the gist of it. So what that's going to do is it's going to cut out the sides on either side of it, an X amount, and then you're able to fold up the side to make a box. So each side was flat, gets folded up to where we have a box here now. And I'm going to put my corners in it. So that's really what's going on with this sheet. So if you think about it, each side's going to be 12 inches long, but we're cutting an X amount from each side. So when we're expressing the volume of the box, so if this is the sheet of metal, we're notching out each corner. And it's going to be an X amount from each seal. So what this really becomes is, each side is going to be 12 minus 2x. X for this side, X for this side, and then whatever's left in the middle. Now there's two of those sides. And then lastly, our height is going to be whatever that X is. So, if we FOIL this, 12 and 12 make 144. 12 and 2x would be 24x, and there's double of those, so minus 48x. 2x and 2x would be a plus 4x squared. And when we distribute the x in, we're going to get x and x squared and x to the third as our v of x function for part A. B, find the domain of V. Well, what's the smallest they could be? Well, we could take nothing out, but then we're not going to have a box. We need to have at least something notched out so we can start folding it up. So from 0 up to, well, what's the most x could be? Well, x is coming from each side. So if the whole thing's 12, the furthest we can come in each way is halfway, which is 6 inches. Now we can't get to 6 inches because then we're cutting it all out and we're not going to have anything left. But that's how you would set up. So this is part A. This is part B. So, but that's how we're looking at the domain is what could x be? Well, we could cut nothing off, but we're not going to have a box. So we have to have at least a little something. So something bigger than 0, but not including 0. Well, we can't go more than halfway because we're cutting in from the other way as well. So that's why we're maxed out at 6, but we're not actually getting to 6. We're just up until 6. All right, so this could be something anybody could be doing sometime. Is let's say you have 140 yards of fencing to enclose a rectangular garden because you do not want those pesky rabbits getting in and eating your cabbage or lettuce, whatever you have in there, or green beans or tomatoes, whatever it is. But anyways, express the area of the garden A as a function of one of its dimensions x. So 140 yards of fencing. Fencing's going to go around the outside. So if this is our garden, we don't know if we're dimensional, but we know this is going to be x, this is going to be y. So area now would be x times our y. But we know perimeter is going to be 2 times the x plus 2 times the y. Because it's twice the width plus twice the length. 140 of fencing is going to go around the outside, so that is the perimeter. Even though we're trying to find the area of the garden using this, we're going to have these two things in order to find out our equation, but we want it to be in terms of x. So what we're going to do is we're going to solve this perimeter equation in terms of y, so we can sub it in here and only have x's. So perimeter is 140. We know our distance around would be 2x plus the 2y. So if we solve for y, we would subtract the 2x over. So in other words, 2y equals 140 minus 2x. We'll then divide by 2. So y would equal 70 minus x. And that's what we're going to put in here to our area equation. So area becomes x times 70 minus x. Because if we solve for y in our one equation, we know what y is, we can sub that in for the y in our area, and then all we gotta do now is distribute that x in. So our area, a of x, is gonna be equal to 70x minus 2x. So if x is the width, whatever width we decide, we can put that in, and that'll give us our area. And we can go from there. Now, a cylindrical soft drink can is to have a volume of 12 fluid ounces, approximately 22 cubic inches. So this would be like a Mountain Dew or Dr. Pepper can. Pepsi can if you want to go there. Or Coke can. Either way, a pop can is what we're talking about here. So express the surface area of the can A in square inches as a function of its radius r. So surface area we know is going to be, and this is for a cylinder, 2 pi r squared plus 2 pi r h, h being the height. We know volume is going to be pi r squared h. So what we want to have here is only radius, so we're going to start with our volume since we know it's 12 fluid ounces. Is 22 cubic inches total. We can put that in for volume and solve for h so that we can sub that in here for the h and only have r's because we want to have it in terms of r. Because we only want one variable here. The more variables you have, the more unknowns you need to find. So we're going to try to narrow this down. So volume we said was 22 cubic inches. So 22 would equal pi r squared h. So to solve for h, we would divide by pi r squared on both sides. So h is going to end up being 22 over pi r squared. So now we can sub this in to our other equation. So surface area equals 2 pi r squared plus 2 pi r, and h is 22 over pi r squared. So pi and pi cancels, one of the r's cancel, and 2 and 22 make 44, so surface area ends up being 2 pi r squared plus 2 and 22 would be 44 over r. And there we go. Now, I'm going to tell you right now, we're not going to worry about this problem here. So, last problem that we're going to worry about. So, you inherit $16,000 with the stipulation that for the first year, the money must be placed into two investments expected to pay you 6% and 8% annual interest, respectively. Express the expected interest I as a function of the amount of the money invested at 6% x. So, x is our 6%. Y then would be our 8%. And it's the amount that we're doing of that. So if you think about it, our x plus y has to be 16,000. Okay? But to find interest is going to be, well, the x amount at 0.06, so 6%, plus the amount at 0.08, 8% of y. Now, if we want to be in terms of x, we're going to take this one here and solve for y, which all we got to do is subtract x. So that's what we can put in for y. So I is going to equal 0.06x plus 0.08, 16,000 minus x. So distribute that in. So I is going to be equal to 0.06x plus 0.08x. And 0.08 times 16 is going to leave us with 1280. This will actually be subtraction here because it will be a minus x. So 0.06x minus 0.08x, we end with 1280 minus 0.02x. And that's it for this equation, or this lesson, sorry. Let me know if you have any questions. Otherwise, we'll talk to you later, guys.